So the last big vocab term in graphing polynomials is this concept of multiplicity. And what multiplicity means, literally, is really how many multiples of a factor do you have in an equation. So let's go through this table where I'm going to describe everything important in this polynomial f of x. And along the way, we'll see what multiplicity is and how we use it. So I'm going to go one by one through the factors. The first factor that I see is x minus 1. Now, if you remember, I'll just do this first example right here. Then I won't go back to this in such detail. We'll say x minus 1 equals 0. So what is x? Well, you just balance the equation, you get x equals 1. So I would say in this graph, the x-intercept is at 1. Or if you want, you can write it in xy notation. 1 comma 0. X equals 1, y equals 0. The y-intercept we'll get to later. Now the multiplicity on this factor of x minus 1, take a look at the exponent. It was 3, right? So that is the multiplicity, which means if I were to write this out without exponents, I would have 3 factors of x minus 1. X minus 1 times x minus 1 times x minus 1. It would be 3 times. Now, a 3 is an odd number. Okay, so this odd number right here is going to lead us to the conclusion that the intercept behavior is crossing. It's going to cross the x-axis at x equals 1. Let's keep going, and I'll show you what these mean when we get to the graph. X plus 2 has an x-intercept at negative 2, a multiplicity of 2, see its exponent right there, and it has an intercept behavior because 2 is an even number. This multiplicity right here is even. That means it's going to bounce, and I'll explain why it crosses versus bounces in a moment. And then the last one, the last factor is negative x minus 3. And if you solve that equation, negative x minus 3 equals 0, you'll get negative 3 for the x-intercept, where it has a multiplicity of 1. See this exponent right here that I just drew in there? 1 is an odd number. If you don't see an exponent, that's what it is. And because it's an odd number, it's going to cross. Now, here's where we get into making a graph out of this thing. I just want to write 2 more things down. The power function, which I'm just going to do in my head real quick. And hopefully you can too. From looking at the factored form, the important thing to me when I'm trying to figure out the power function is what kind of factors of x we have. There's an x, there's an x, there's a negative x, there's a negative 3 up front, and if you add up the exponents, that's 3, 4, 5, and 6. So, putting this all together, boop, 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 I have a power function of, well, negative 3 times negative x to the 6th is 3x to the 6th, and that is positive even. Okay, that's positive even end behavior. So let's take that information we now have about the end behavior and put this all into a graph. Here's how it all comes together. I've got x-intercepts at x equals 1, x equals negative 2. I'm looking at the table up top, and x equals negative 3. Those are my x-intercepts. I have an end behavior, which is positive even, which means it's going to look something like this. Okay, it's going to hit those x-intercepts, and then it's going to go up and up. And I haven't talked about the y-intercept yet. I should probably mention that. The y-intercept is going to be negative 3 times negative 1 cubed times 2 squared times negative 3. I set all those x's equal to 0. And if you multiply all these numbers up, let's see, I've got 3 times 4 is 12. Negative 36? I think that's a very large intercept. Let's see, is that right? 3 times 3 is 9. Yeah, I think that's right. Okay, so negative 36 is our y-intercept. We'll just put that guy on this graph, and we'll see if it all makes sense. Just pretend that's negative 36 down there. So the first x-intercept, or the first one in my table, I should say, is right here. And it says I should cross the x-axis at x equals 1. So down we go. We cross right through it. I'm going to hit that y-intercept right there. And let's go to the next x-intercept, which I'm told is at negative 2, and it's a bounce. Okay, so we're going to negative 2, and I'm going to bounce off of it. And then I go over to negative 3, right here, where there's another cross. Now, you can see this graph leaves some artistic value to be desired. right? Come on, what is this stuff, right? Don't worry about that. When you're making a graph or when you're reading a graph, the important things for you to look at are not how nice these lines look and how wavy or pointy or curvy they are. It's these important things. Where does it hit the axes? And what does it do when it hits the axis? Is it a bounce or is it a cross? Okay, so that's generally how you graph these things. And if that's all you were looking for from this video, great, you can tune out now. I just want to go over, if you're interested, why it's a bounce versus a cross. See how this x plus 2 comes from a squared? Remember what squareds are. Those are like parabolas, right? We'll take a look. Let's zoom in on this guy. Look, it's like its own little parabola right there. But these other ones, where you have a multiplicity of 3 or a multiplicity of 1, think about what x to the 1 looks like. It's just a straight line. It's going to cut through an axis. Or x cubed, think about that. That one is a wiggly line, but still it's going to cut right through an axis. Well, that's what these things do at their respective places. They cut through the axis. The only things that bounce are things that look like parabolas when you have a squared or a fourth power.